We are live. All righty then. Good evening, everybody. Welcome to Saturday Night Rabbit Hole. Tonight's topic Mendocino Lineament and its history. Yep, we just had a 7.0. It started with a 6.6, got upgraded to a 7.3, been downgraded to a 7.0. And so it's somewhere in between there. And for some, it was a rabbit hole. It was a rabbit hole because they didn't know where it was going and when it was coming and how far it went. But it was super shallow. I mean, it was under a mile deep. And right there where it hit was about 3,000 feet deep. If I can verify that now, I will. Let me grab a couple of items here for you. And we go on the 7-day. Go over to here. I'm just picking up hey, there we go. All right there. Yeah, they can still have it as a 7.3 or a 7.0. So here we go. So going to Google Earth, and I'm going to find it for you. They don't like these things here. I think is that a negative? It is. All right. So yeah, 2,100 feet deep. So let me share not a cam, share the screen. I understand. I don't know why they keep doing that to me. Let's share that. Go back to here. Share it on screen. All righty. So this is the epicenter of the 7.0. Here's the links here at USGS. They have it at 10 kilometers depth. They've since changed it again.
Yeah, they changed it. I saw them talking about it.
Yeah. I mean, it was 0.6 last time I looked. Yeah. If we went to the tsunami people, and they'll tell us what they have it as. See, they have it as a 7.3. It came in. And 8 miles now. They have it 8 miles deep. Yeah, so they have it at 8 miles deep, and USGS has it at 10 kilometers. So probably 8 miles.
Yeah, after they reviewed it, they put it down to 7. Because the computer detected at 6.6, and then it upgraded it to 7.3. And then after they looked at it, they downgraded it to 7. Because I found a thing where they were on the CBS station out there talking about it. So they had two people from USGS, and there was people calling in and reporters asked them questions. So it was like a 10 or 15 minute thing.
Oh, okay.
So they were asking like how come, like why it came in at 6.6 and then was upgraded and all that. So they explained how they
Okay, what did they tell you?
Well, they basically said that was the computer detection.
So was the computer right or was it wrong?
Well, after they reviewed it, that's when they decided it was 7. Basically. So after the seismologists reviewed it, they said it was a 7.
Yeah.
So at first the computer said 6.6 when the alert was sent out to the big alert thing. And then it was 7.3 for a little bit, and then when they reviewed it, they put it back down to 7.
Yeah, remember everybody, it's not based upon the actual, the old way of doing things. It's the new way of doing things.
And then the reporters asked them about the tsunami alert, and they said, well, we're not responsible for that, because they said that was based on what NOAA calculates. So they deflected the questions about the tsunami.
All right.
alerts that the reporters had for him. It was about a 10 or 15-minute interview, so there's all sorts of people, other reporters asking interesting questions.
All right. All right. Well, it comes out to pan out that sequence only produced 292 quakes thus far.
Wow, yeah.
And no fives. No fives at all. That's
but the people that have been watching it all the time on the seismos,
mm-hmm.
a bunch of different ones have said that they're about an hour to 2 hours behind reviewing the quakes.
Yeah.
Because they're seeing them live on the seismos, but then they don't show up till an hour or two later because they have to review every one before they put them on there.
Good evening, Luke. Thank you for showing up. Just wanted to say hi. Well, if you didn't know, everybody, this is Joe Slick, and I have the Snow King, the Snowplow King, and I have Canuck with me this evening. We're going to talk about the Mendocino Lineament, what we're calling the lineament, and its effects, and important in a little bit of history that we have, and how busy is this darn thing? So that's kind of what we're looking at. And obviously having a 7.0 right here, bang. And the earthquake happened out here, but it seems like, well, why didn't the earthquake continue left? Why didn't it go north and why didn't it go south? Well, it looks like it went east and a little bit dip toward the south. And what we notice that there is a plate boundary right there. So it's following the plate boundary. That plate boundary turns into, can you tell me? Yeah, the San Andreas Fault system right at the top here. So this is not on the San Andreas, but it's at the tip of the San Andreas. It's on the triple junction. You have the Cascade subduction zone up here. And then we have the Mendocino Ridge right here. And then we have the San Andreas down here. But let me ask you a question, Canuck, or even to Luke. Is the Gorda Escarpment or the Mendocino Fracture Zone, is it part of the San Andreas? I mean, the Pacific Plate.
The Pacific Plate is running, that's where it's running into the Gorda Plate. That's how they explain it. And it's going to explain it in the the Mendocino Triple Junction thing. So that's why.
All right, so we're getting there. We're getting there. Let's see. Kitty Cat says also as important is to note that seismologists have multiple ways of determining magnitudes now. The 6.6 was a local magnitude, which is easy and fast to calculate, so it gets reported first. The 7 is moment magnitude. That's the difference. Moment magnitude versus the mercantile magnitude, right? So the moment magnitude started, let me see, when did that start? Let me ask that question. When did it start? In 1979, a moment magnitude scale was introduced by seismologist Thomas Hanks and Hiru Kanamori, making it the successor to the Richter scale for measuring earthquake magnitudes. Purpose was to provide more accurate measure of large earthquakes compared to the Richter scale. Magnitude was defined in 79 by Hanks and Hiru, similar to the local magnitude Richter scale, or ML versus MW, defined by Charles Richter in 1935. It uses a logarithmic scale. Small earthquakes have approximately the same magnitude on both scales, but what do we see here? The moment magnitude scale, MMS, denoted it explicitly as M or MW or MWG, and generally implied with a single M for magnitude. It is measure of an earthquake's magnitude, size, or strength based on its seismic moment. Was defined in 79 by Hanks and Katamori. Similar to local magnitude Richter scale defined by Charles Richter in 1935 that was. It uses a logarithmic scale. Small earthquakes have approximately the same magnitude. Despite the differences, news media often use the term Richter scale when referring to moment magnitude scale. That's the confusion, everybody. Even moment magnitude is considered an authoritative magnitude scale for ranking earthquakes by size. It has significant limitations for measuring earthquakes, small and medium earthquakes for all over the world. It is directly related to energy of an earthquake that other scales and does not saturate. That is, it does not underestimate magnitude as other scales do in certain conditions. It becomes the standard scale used by seismological authorities, like the USGS, for reporting large earthquakes greater than 4, replacing the local magnitude, right, which is the old way, of surface wave magnitude, that's M/S, scales, subtype of the moment magnitude scale of MWW, etc., reflect different ways of estimating the moment. So I think there's a lot of confusion on that. Seismic moment is a measure of the fault slip and area involved in the earthquake. Its value is the torque of each of the two forces couples that form the earthquake's equivalent double couple. More precisely, it is the scalar magnitude of the second order moment tensor that describes the force components of double couple. Seismic moment is measured in units of Newton meters, or joules, or in the older CGS system, dynacentimeters. The first calculation of earthquake, the seismic moment from its seismic waves, was by Keith Akey in 1964. Niigata earthquake. He did this 2 ways. First, he used data from the station to analyze the period of 200-second seismic waves, wavelength of about 1,000 kilometers, to determine the magnitude of the earthquake's equivalent double couple. Second, he drew upon the work of Burridge and Knophoff on dislocation to determine the amount of slip, the energy released, and the stress drop, essentially how much of the potential energy was released. In particular, he derived an equation that relates to the earthquake's seismic moment to its physical parameters. So they're doing a whole lot more than just magnitude, watching the scribbles on the lines. So and a key thing is measured in joules. It's the amount of energy released. And I think the other one just measured how much it shook, right? So, I mean, obviously it's the new way and it's probably the right way, but I hate it.
I'm not a fan of it either at all, because I don't like how they play with the numbers.
Right.
I mean, if it's all, let's say you get on the old way, let's say it's a 6.5. Well, the new way, if it's out in the middle of the ocean, they might knock it down to a 6.1 or 6. But let's say the same quake happened on land around a bunch of hay huts and brick buildings, and it leveled the place. Well, they're going to bump it up to almost a 7.
Right.
I don't like how they play with the numbers. If it's a 6.5, it's a 6.5. It shouldn't, you can throw your moment magnitude number in there too, but, at least report the old way too, still.
Mm-hmm. Yeah, there's
Go ahead. That's why all historic quakes have a range on them now, right? Because they've gone back and redid it based on the damage reports and everything that they put into the computer models, and that's why they give it the range now.
Yeah. In essence, what a 7 does, it's the equivalent to 38 Hiroshima bombs. 475,000 tons of TNT, or 2 joules times 10 to the 15. That's the amount of energy. So 38 Hiroshima bombs, that's pretty good freaking bomber.
That's a lot of power.
You know? And 8 is 12,000 Hiroshima bombs, and a 9 is 38,000. No, 1,200. 8 is 1,200. A 9 is 38,000. And a 10 would be 1.2 million equivalent Hiroshima bombs. So a 9 will produce 475 million tons of TNT. 7 produces 475,000, and 8 is 15 million tons of TNT, or 1,200 Hiroshima bombs. So there's a huge step from 7 to 8, and an even more huger step from 7 to 9.
Yes.
That's 1,000 times more powerful, a 9 than a 7. That's pretty crazy.
That's
And
a huge amount of
a
power.
5 is 0.03 of a 7. And a 6 is 1.2 Hiroshima bombs. And again, a 7 is 38 Hiroshima bombs. Pretty crazy. And yeah, not something to play with. But Canuck has already dropped in some links. Let's talk about the Mendocino triple junction. I'll let Canuck read.
Okay, I'm just gonna read it off because it explains like how it works and the north-south compression and all that stuff. So it's pretty good. So the Mendocino triple junction is the point where the Gorda Plate, the North American Plate, and the Pacific Plate meet in the Pacific Ocean near Cape Mendocino in Northern California. This triple junction is the location of a change in the broad tectonic plate motions which dominate the west coast of North America, linking convergence of the northern Cascadia subduction zone and translation of the southern San Andreas fault system. This region can be characterized by transform fault movement. The San Andreas also by transform strike slip movement, and the Cascadia subduction zone by a convergent plate boundary subduction movement. The Gorda Plate is subducting towards north 50 degrees east under the North American Plate at 2.5 to 3 centimeters per year, and is simultaneously converging obliquely against the Pacific Plate at a rate of 5 centimeters a year in the direction of north 115 degrees east. The accommodation of this plate configuration results in a transform boundary along the Mendocino fracture zone and a divergent boundary at the Gorda Ridge. This area is tectonically active historically and today. The Cascadia subduction zone is capable of producing megathrust earthquakes on the order of magnitude 9. Due to the relative plate motions, the triple junction has been migrating northward for the past 25 to 30 million years, and assuming rigid plates, the geometry requires that a void called slab window develop southeast of the Mendocino triple junction. At this point, removal of the subducting Gorda lithosphere from beneath North America causes a stenospheric upwelling. This instigates different tectonic processes, which include superficial uplift, crustal deformation, intense seismic activity, high heat flow, and even the extrusion of volcanic rocks. This activity is centered on the current triple junction position, but evidence for its migration is found in the geology all along the California coast, starting as far south as Los Angeles. Then it talks about the slab window model and triple junction migration next.
Okay.
The passage of the MTJ causes mantle material to flow into the region vacated by the Gorda Plate. Once this hot mantle material is south of the triple junction, it cools, stiffens, and accretes to the adjacent lithosphere, eventually welding to it and moving along it with it, analogous to the motion of a conveyor belt. Lower crust, upper mantle viscous coupling plays a dominant role in converting accretionary margin materials into continent-like crust. Researchers were able to demonstrate that in this conveyor belt mechanism, the crust is first thickened north of the triple junction, and after passage, the crust is thinned south of the triple junction. In this way, as the MTJ migrates, there is production of basal, I think, but maybe it's basalt they're supposed to have. Conveyor belt beneath
basal.
Yeah. Beneath North America that transports material from the south to the north. This is consistent with an observed pattern of an anomalous crustal structure determined by local earthquake crustal tomography in the region. Geolithology section. The region is dominated by Mesozoic to Cretaceous age rocks, which make up an uplifted subduction zone, accretionary wedge called the Franciscan Complex. This unit is made up of sandstone, shales, cherts, meta-gray, whatever that is, wax, melanges, as well as mafic volcanics, and is mostly metamorphosed to blue schist and eclogite facies. Now that thermal regime section.
Yeah, the basal conveyor is it's a form belongs to the bottom layer or the base of the epidural. So there is a production of base conveyor belt beneath North America that transports material from the south to the north. This is consistent with the observed pattern of anomalous crustal structure determined by local crustal tomography and in the region. So they're talking about Baja to BC, basically that's still continuing, but not at the same time period as the other one.
Well, yeah, the Pacific Plate's running into the Gorda. Still. Which on where this quake was is actually on the Pacific Plate, not on the Gorda. Whereas the other times, like there's been other quakes that have been on the Gorda one, but we'll look at that after. Yeah. So now back to what one was I on? Oh, the thermal regime. The spatial distribution of heat flow in the vicinity of the MTJ is similar to what would be expected in a subduction environment. That is, heat flow is low above the subducting Gorda slab, between 40 and 50 megawatts per square meter. South of the MTJ, heat flow through the California coast is higher, around 90 megawatts, I think it is, per square meter. The distance south of the MTJ over which heat flow increases gives an indication of the timing of development of the heat flow anomaly. He observed surface heat flow doubles over a distance of 200 kilometers, corresponding to a time frame of migration of 4 to 5 MA, so million years, I guess. It is also consistent with the source for the anomaly thought to be a stenospheric mantle material and placed at shallow depths of 15 to 25 kilometers in the slab window. Because there's been some of the quakes there that are in that range. 15,
right.
20.
So they're saying it's that area is how deep?
15 to 25, I guess, based upon Gorda Plate. That area right there must be 15 to 25. Yeah. This rise of the heat flow anomaly time implies that there is probably only a thin crustal lid above the slab window. Okay, genesis of volcanics. The presence of hot astenospheric mantle at shallow levels beneath the western margin of North America is likely to generate melt and cause magmatism. Accordingly, a sequence of volcanoes in the wake of the MTJ passing were activated. This magmatism likely leads to the intrusion of plutons with the overlying crust in the region. Now it gives the example. Example of volcanic bodies that form by magma upwelling and solidification are the Nine Sisters, located between Morro Bay and San Luis Obispo in California. The source of the material which flows into the slab window is a matter of debate, specifically whether it is derived directly from the underlying mantle or from the mantle wedge to the east. So the chemistry of the erupted basalts associated with the MTJ are typical of mantle wedge derived melts characterized by enrichment in the large ion lithophile elements and depletion in the high field strength elements. In general, mantle wedge derived melts are relatively more hydrous, have lower viscosity and temperatures than melts derived from sub-slab mantle. Okay, now my favorite section. Most of the seismicity near the MTJ is offshore, concentrated along the Mendocino transform fault. Seismicity is also distributed within the Gorda Plate itself, owing to its small size, young age, and relatively thin lithosphere. Oblique convergence of the Gorda Plate towards the Pacific Plate causes intense north-south compression and induces enormously strong internal deformation in the former, giving rise to the Gorda Deformation Zone and resulting in abundant seismicity. Motion along the Mendocino Transform Fault is right lateral on east-west oriented vertically dipping plains. Within the portion of North American crust overlying the Gorda slab, motions on the faults is reverse. And then it gives an example. And in April 1992, a magnitude 7.1 earthquake ruptured the southern portion of the Cascadia subduction zone. Similar to the general seismicity patterns in the region, the majority of the aftershocks for this event had vertical strike-slip motions and were located within the Gorda Plate or on the MTF at depths between 23 and 35 kilometers. None of the aftershocks were consistent with northeast underthrusting of the Gorda Plate beneath North America, as was the case in the main event. This set of earthquake geometries implies a stress field characterized by north-northwest horizontal principal compressive stress consistent with the orientation of compression in the GDZ northwest.
Gorda
zone. So those quakes in 92 were actually mainly on the Gorda Plate, and they didn't progress like in farther underneath. Yeah. So kind of like what it's doing right now, except this is down a little bit lower this time. So the original, well, we're going to look at it, but in 92 there was a 7, but then there was a whole bunch of 6s too, like all around the same time. Where this we've just had.
Yeah, I'm looking it up now.
7 so far. So that's what we're going to look at next, because that one I put in there has all the Pacific Northwest quakes on it going way back.
The Cape Mendocino 1992 was onshore, though. That's the only difference.
Yeah.
So
yeah, the first one, I think the 7 that they're talking about was underneath or onshore, but then all the aftershocks after it were all out on the Gorda Plate itself, because there was a whole bunch of them in 92. And this was all
yeah. I remember 92 very well.
yeah.
The main
And
shock
this-
generous small tsunami recorded the sea level gauge. Series of first wave came across this. First peak energy didn't tell me how high though. 14 inches was the tsunami. Another 21 inches. Yeah. Usually when we have a tsunami, there's multiples. In the 1992 ones, but in this one there was no tsunamis. It's kind of weird.
well, if the first one was inland, see, it wouldn't make a tsunami, right?
So how do we describe in layman's term what is going on here? You know, we got the I'm drawing.
Well, because it's a convergence zone, you're getting pressure coming from both the north and the south into that area. That's what it seems like to me. And then when you look up these quakes, sometimes it comes down and goes through and makes a big one to the south, or other times it goes east. So it's pretty interesting. Because see, in 92, when we had all the stuff that was on the Gorder Plate, well, and it was going crazy in 91, if you look at it too, because that's when all those crazy Oregon quakes. So they were up just a little bit closer to the Oregon side, because it lists them all there. See all those ones in 91, and then all the ones in 92, all before landers went off. So I find that super interesting. But see, then it was Petrolia acted up, and Mendocino acted it up again in 93. That whole area again, the Gorda Plate, MTJ. We see it's doing it again with 3 notable quakes in 93 before you had Northridge.
All right. So if we're looking at the Mendocinos, here's the straight line, right? The San Andreas is the orange one down below. The Cascade is the one up in north. This orange line or the brown one is the coast. All right. So, and the border of California, this is Oregon. Whoops. Oregon, OR and CA. Okay.
Yeah.
How did they say it's moving? I mean, out to sea, we know the Pacific's moving about like that, but it sounded like that it's moving. Whatever was it? Seismicity. It's not under seismicity. What was it?
Well, basically, I think what they were saying and all that thing that they said, anything coming down from the north or is causing the Gorda Plate to go under to be subducted. But the other stuff coming up is what's pushing the Pacific Plate into the Gorda Plate. Because, see, they're referring it to at the MTJ, which is...
Right. The region can be characterized by transform fault movement. Yeah, transform fault movement is basically San Andreas, right? So the San Andreas also by transform strike slip movement. The Cascade subduction zone by convergent plate boundary subduction movement. So we have convergent subduction.
But it's not just the San Andreas because the Bartlett
right. I know that. I got you.
Right.
Yeah, I'm just trying to figure out which direction is going. Transform strike slip. So this is trans strike. And then it says The Gorda Plate is subducting towards north 50 degrees east. How do I find what north 50 degrees east is?
Well, I assume those are the coordinates, I guess. Like what direction it's going.
Towards north 50. That's what I was trying to look up earlier. Because I put on I really want to know, show the grid lines here. Show this tab instead. Share this tab. I want to north 50 degrees. That's the quake here. This is the quake in 92. Here's 40 north, and it said towards 50 north, right? Yeah, the Gorda Plate is subducting towards 50 northeast. Where the hell's 50 north? Way the hell up here, right? Here's 50 north right here. And see if I can. I know there was a way to do it. There's 50 north. All right. So it's subducting toward 50 north, which is basically due north, right? Streams can be characterized by transform fault movement. The San Andreas also by transform strike slip movement, and the Cascade suction by convergent. Now, convergent we know as being compressional. Transform is strike slip. 2.5 to 3 centimeters a year. Pacific plate rate is 5 centimeters a year, direction of 115 east. So where's 115 east? Well, shoot, there's one west. All right, 115 east. Is there an east? Okay. Here's 120 east. So 115 east is right here. So this is 115 east. East, which is just south of Taiwan. And someone is converging obliquely against the Pacific plate at a rate of 5 centimeters, directing. Well, that's the North American is moving that direction. So North America is moving where this right across the Tropic of Cancer. It's actually moving a little bit south, right towards Taiwan, call it. That's the direction of North America. And transform strike slip and the cascaded subductions, blah, blah, blah. The Gorda plate is subducting in the north, straight up, basically. Under the North American plate, simultaneously converging obliquely on one side against the Pacific plate at a rate of whatever in the direction of due east. All right.
Well, I think this quake is from the stuff coming from the south.
Well, yeah. First, I want to understand how what's going on in that area, right?
Yeah.
So we have the North American plate basically going towards Taiwan. We have the Gorda plate, which is up just above us, going due north, basically, because we're at 41 north here, and it's going all the way to 50 north. It doesn't really say 50 degrees north or 50 degrees northeast. I don't know how to even freaking call that, because it's not telling me. And from what I understand, it's going, into Vancouver Island basically. And that's how this portion of the Blanco fracture zone is going diagonally. And so this part here, and then it said a slab window. Due to the relative plate motions, the triple junction has been migrating northwards for the past 30 million years. There's our number again, right? Do you remember that number? 30 million years.
Yep, 30 million.
Well, they're saying all that melt is coming up from a slab window that has to do with the Gorda plate, because that's all new, super new stuff.
Right. Because there's a break in the
They're saying all these volcanics that we've been talking about, basically in Northern California.
Right. Yeah. We're going to get to that real fast here too, because Medicine Lake volcano and Lassen and Reno.
And see, they're showing it on that map there that's right beside it. See, they have them all listed. They have the red.
All these down here, you can see.
And see, Lassen lines right up.
Or Lassen's right on it. I know, man. That's so.
Which that's basically what it did in 1915, because it was going batshit crazy out there. 1914 through whatever 22. If you're looking back on the chart or the table thing I put in there. So to me, it's making more sense now.
Yeah, the geometry requires a void called a slab window, developed southeast of the Mendocino or MTJ in Mendocino triple junction. South of it, developed south of it, southeast of it. At this point, removal of the subducting Gorda lithosphere and beneath North America causes the asthenospheric upwelling. This instigates different tectonic processes, which include superficial uplift, crustal deformation, intense seismic activity, high heat flow, and even extrusion of volcanic rocks. This activity centered on the current triple junction position, but evidence for its migration is found in the geology along the California coast, starting as far south as Los Angeles. That's what we all talk about a lot when we go back 30 million years. We have to move the Mendocino down to Los Angeles.
Yeah, because it's the San Andreas has been around for that long, right? So that's how these numbers are coming together. So I imagine Sutter Buttes has something to do with this upwelling that's in the slab window, and probably a bunch of, well, they're saying that a bunch of the coastal range stuff there is too, because it gives they're the ones that are down by Morro Bay and San Luis Obispo gave that example in there. So they're saying all of those were all created by this slab window over however long.
Right. A slab window. Here's a diagram of the slab window.
And it's moving up, right? So
basically it's a void.
Doing all this stuff, yeah.
It's a void. That's what a slab window is. I'm showing it on screen. And this one happens to be part of South America, the Antarctic, the Nazca plate, the South American plate. This is like really oriented, funky too.
But what's interesting about that is it's also the same time period for all those super volcanoes going off.
Yeah. And the movement over 30 million years is 500 miles. That's how long it took. 500 miles. So in geology, a slab window is the gap that forms in a subducted ocean plate. When a mid-ocean ridge meets with the subduction zone and the plate divergence at the ridge and convergence at the subduction zone continue, causing the ridge to be subducted. Formation of a slab window produces an area where the crust of the overriding plate is lacking a rigid lithosphere, lithospheric mantle component, and thus exposed to hot asthenospheric mantle. And you can check the diagram. This produces anomalous thermal, chemical, and physical effects in the mantle that can dramatically change the overriding plate by interrupting the established tectonic and magmatic regimes. In general, the data used to identify possible slab window comes from seismic tomography and the heat flow studies. As the effects of a slab window develops, the mantle in that region becomes increasingly hot and dry. The decrease in hydration causes arc volcanism to diminish or stop entirely, as magma production in subduction zones generally results from hydration of the mantle wedge due to the watering of the subducting slab. Slab window magmatism may then replace this melting and can
C class moderate magnitude 5.0 depth 37 kilometers 24 minutes ago.
Can be produced by multiple processes, including increased temperature mantle circulation producing interaction of supra and sub slab mantle, partial melting on subducted slab edges, that extension in the upper plate, mantle flowing upward through the slab window in order to compensate for the decreased lithospheric volume, can also produce decompression melting. Slab window melts are distinguished from alkaline subduction related magmas by their different chemical compositions. The increased temperature causes the presence of a slab window can also produce anomalous high temperature metamorphism in the region between trench and the volcanic arc. This is what's exactly going on in the area that we're studying right now. The geometry of a slab window depends primarily on the angle of the ridge intersects with the subduction zone and the dip angle of the downgoing plate. Other influential factors include rate of divergence and subduction, as well as heterogeneities found within specific systems. There are two end-member scenarios in terms of geometry of a slab window. The first is when the subducted ridge is perpendicular to the trench, producing a V-shaped window, and the second is when the ridge is partial or parallel to the trench, causing a rectangle window to form. So what do you think is happening up there? I think it's a V shape in our study zone here. I'm thinking that, but I could be wrong. If I am, correct me. It's cool. The North American Cordillera, as well as study plate motion, good examples. Effects of slab window can have an overriding continental plate beginning in the Cenozoic fragments of the Farallon plate as the subducted causes slab window to open, and that then generated anomalous features in the North American plate. These effects include distinct four-arc volcanism and extension in the plate, which may be contributing factor to the formation of the Basin Range province. The Northwest Young Permian Permitan Belt volcanism in the Southwest British Columbia, Canada, may have been related to the northern movement slab window edging under North America 29 to 6.8 million years ago. There's 29 million years ago. In addition, a fossil slab window in the Cenozoic seen in North America. There is other regions along the Pacific Rim in California, Mexico, Costa Rica, Patagonia, and the Antarctic Peninsula that exhibit active ridge subduction producing slab windows.
Yeah, so this is all the slab window thing that they're all talking about.
That's what I mean. In getting to it,
because every one of those little plates,
it's basically a tear, right?
Window. Well, Well, they call it a tear window. It doesn't matter. It's all the same.
Yeah, I'm thinking of it as a tear.
It's a
so
crack where stuff comes up. That's it.
right.
Same as the faults, right? Because even where the volcano comes up is through a crack. And that's all the stuff we've been talking about, right? Because it keeps saying, oh, there's a fault that runs right through this volcano. And it's this
Right.
fault. Well, that's how the stuff is busting through to make the volcano. Like, they take all these gigantic words.
Right, and that's
What
the confusing part, I think,
simple
for myself and for others. You know, a triple junction is the point where three boundaries of three tectonic plates meet. The triple junction, each of the three boundaries will be one of three types: a ridge, a trench, or a transform fault. The triple junction can be described according to the types of plate margin that meet at them: the fault trench, ridge, or abbreviated FFT, RRR. One of these possible types, triple junction, only a few are stable, though, through time. Stable in this context means that the geometrical configuration of the triple junction will not change through geologic time. The meeting of four or more plates is also theoretically possible, but the junctions will only exist instantaneously. Well, we got a list here of all the triple junction.
What I think it's doing right now is it's been 2 years since the Colima quake, and it's just getting up to make a 7 up there at the MTJ now. I think that's what it's. And I've seen the same pattern before now that I've started looking at each of the ones.
Right.
That's what it should be doing. For the San Andreas Imperial fault part and going down into the Gulf of California.
Well, I think it's important, like I said, the reason I'm spending a little bit of time on this.
Because we've had 3 6s there right on the coast by Mendocino since the Colima quake.
We've been talking about that for sure.
And now it just went out a little bit farther, right? So we just had a 7 farther offshore.
A little bit
to
offshore,
me, Pacific plate running into it. For this one. But if you look at the other ones, you have to see what was going on before that. And if you look at 92 and 94, it was going crazy up above.
Well, you know, 92 was the Landers quake, the 7.3 in SoCal. So
yeah, which is why it made it so big, because all the stuff that was hitting there in 91 and 92 was coming down as well, because it lists the Blanco fracture zone and stuff. All that's why I like that Pacific Northwest thing, because it's giving me all the see all the other ones, and I have to look because it's given all the 5s too, right? Like mid 5s or whatever in this list, so I can see what it was doing before I can see how it's converging with these lists, which I wasn't paying attention to before until we started doing all this studying on all the faults there. And then now we've talked about the volcanoes, because to me they go together. So the volcanoes,
they are definitely something that works together.
The volcanoes should blow out the more active this stuff gets, like what it was in 1914 to 22, because if you look back in the same list,
even into the 30s, you got Blanco fracture zone right there going crazy too. I'm looking at it.
Yeah.
On screen, we have a list of earthquakes, significant earthquakes in the Pacific Northwest, and we're looking through these: California, Oregon border, Crescent City, 6.7, November 1880. See, they've got a lot.
Like they're going way back, so you can
Humboldt Bay, Chimney Plaster, 5%. Yeah, they're going back to 1700.
Yeah, so you can use it to coordinate.
Eureka area, 5.7.
With the other ones that we've already studied, because see, it went off in 1857, so that would have been after the Fort Tejon quake. They don't know what it was. They just have the date that happened, Eureka intensity 6.
Right,
So they don't
right.
have a bank. And see, it was going off before that 1865 quake that we talked about that was Santa Cruz Mountains, San Jose.
And then you have the 6.4, April 23 in 1906.
Yeah.
And I think the San Francisco earthquake was in January. Am I wrong?
April.
April?
1906.
All right. So
Yeah.
both of them happening. This is why I'm saying I'm still watching San Francisco for the better part of this week.
And see, it
into
was,
the next
it
weekend.
was doing stuff in 1871, 1872 when Owens Valley was.
Yeah, 1872, India, yep, 6.8. Petrolia, 5.9. Eureka, 5.4, 5.7. Humboldt,
And it
5.7,
went off in
1860.
1884, which is when the largest New York City quake was that we know about, right straight across. So
Yep.
I thought that was interesting.
5.7. Yeah.
And then you keep coming down, 1899. See, that was the year of the Yakutat quakes. So it was going off that time.
Yeah, I mean it the whole system, you can't take them as an individual. You have to kind of take them as a system, so to speak. And I think that's what we're doing here. We're trying to locate those systems. And, I know I spent a little bit of time trying to define some of these things, but a lot of people don't know it. Hell, I don't know half the damn things. And in looking at them is like, hey, all right, how does this thing go? All right, it's spreading here, but it's pushing down there and it's ripping here. It's creating a slab window. And that slab window is allowing magma to rise to the surface and dry out the land, I guess. And then it stops in one sense, it stops the volcanic stuff from doing it. Maybe that's what's been doing that, man. But
I think it goes together. So if it does it enough, you get an eruption blowout.
Yeah. So if indeed the coastal range there in the Mendocino area, right? There's no volcanoes there. We have to go interiorly to Shasta, and then we have to go interiorly to Lassen. But south of that, we've got Clear Lake Volcano, Mount St. Helena, and those are like Clear Lake, and then there's Sibley volcanic area and Round Top, which are just near Diablo, right there in the San Francisco area. Yeah. And then you got to come down to Pinnacles, and then we have the one that's the other half of Pinnacles, that right there at 3 points, right? So I mean, it's the Neenach volcano, right? So
and if you keep going down through that list, it was doing crazy stuff up there when the San Jacinto quakes happened, which were the ones we talked about before, like 1918 to 22, I think it was. You'll see all that same area was going back shit crazy. 25 was the Santa Barbara quake that we traced. And then 27 was the Lompoc one. So if you look down, see that whole area all up around there was going nuts. At the same time, these other quakes that we've studied already were happening. And then 32, see how many were going off in 32? So that was right before we had the Long Beach quake in 33.
Right.
And 32 was also a big Klima quake, 8 point whatever one. So it's like this whole section was like going crazy, like over 2 years.
Hey, I think the Sierra Nevadas, the volcanoes in the Sierra Nevadas ended in 80 million years ago. But some of the volcanoes that we've talked about, 30 million years seems to be it, right?
Yeah.
And if we move Mendocino south, because it's going north, if we move Mendocino south and it's at Los Angeles 30 million years ago, and we move North America the same distance east, we probably uncover Farallon, and this,
At least a portion of it.
yeah, I mean, Farallon seems to stop right there at the Mendocino, the bottom of it. But I have
Yeah, but they say that's now the North Farallon, and then there's a South Farallon, right?
Yeah, the North Farallon would be up there in Vancouver. This is in the South Farallon, am I right?
Yeah, what we're talking about now would be the North Farallon.
The North. Where's the South?
That's everything down farther. Because now they're saying there's 2 Farallons. Plates.
All right.
The north one and the south one. So basically everything south of the MTJ now would be the south slab.
So they believe there's a slab underneath somewhere.
Yeah, that's under there.
Did the plate crack in half to divide, or what happened?
Well, this is why they're saying that there's breaks between it, but maybe it was already that way in the first place. This is why I said how they tried make it is too simplified, because based upon the examples we have now for plates, there's all these different piece ones, and when you figure that out, you're creating a whole bunch of triple junctions where you have all these cracks where magma can come up, right? And this is what they're finding out, because see, they're doing the mantle tomography and trying to match it with everything else, and that's what the debate is about. Well, what caused the magma to come up here and why? So why is there plutons way the crap out in Idaho or wherever they're talking about, way up in BC, way inland? See, this is what they're trying to figure out. So there had to be some crack, or whatever they want to call it, slab window. It's just a crack, a big crack between all these plates that they're coming up, giving them different names, where the magma came up through. That's what it is. And it does this all over, right? Like it's doing it everywhere. And it's just that they're trying to figure out which break caused the magma to come up between all these plates that have been subducted. And this is what they're doing. And now, because you can see that stuff in the mantle, whereas a few years ago, you didn't know what was down there. So now they're all trying to recreate this all back again. But to me, it's a straight, I'm trying to make it simple, and they seem to be.
Right. But for me, I work with definitions, and that helps me understand things. So that's why I have to go back and, take that links and then say, okay, this is what a triple junction is. All right. It's 3 pieces, 3 plates coming together doing what? Well, sometimes one's like spreading apart, one's going under, and one's pushing them both, or vice versa.
But see, the more plates you have or identify, then you're creating more triple junctions, because you're making more plates interacting together. So you're getting more cracks where magma can come up between all these plates. So
correct.
You're giving each plate that you identify now a new name, right? Or some of them have 3 names, because it just depends on who's talking about it.
Right.
So it gets more confusing, but it's the same as like if you were naming pieces of ice breaking up on the river. It's the same thing. Because some are going up and going on top of the other one, so they're accreting to it. Some are subducting underneath. So, like if you followed a piece of ice and gave it a name, it's doing the same thing. It's just
I got you that. And I don't know how much that helps me discover what the hell's going on. You know,
And all these things are moving from, well, what I think it's the core magnetics moving everything. And
of
that's
course.
what it is.
And they're talking about, I think, did you
In a
see
river
the,
and ice, it would be the current of the water moving it. Right.
right? You saw what was Professor Nick and that lady he had on the other day? That was really, really insightful about looking at the volcanoes in the Pacific Northwest. The dead ones look this color, the live ones look this color, and it's talking about magma and water moving. They don't know what it is, but they know it's got heat.
Yeah.
And this triple junction, I can't imagine they're looking at it, the triple junction, doing the same things that this gal's doing. It's like, wow, man,
So probably if you could go back in your time machine to whatever date that was happening, there's probably a crap load of earthquakes that was happening at the same time when all that was going on.
you know,
Just like what it's doing now in Iceland, right? It's the same thing. So
yeah, I mean, it's
because I think it's all related. It's always.
I mean, Iceland is really showing us what's been happening. You know, it really shows us how magma comes up, right? So it's not something that's you can take just.
Yeah, and it goes through to whatever way it can find through the cracks to get to the surface.
Mm-hmm.
And so sometimes it's going to blow out in all sorts of different places depending on what pathway it finds to come out, which is basically what it's doing, which is why you have all these volcanics all over the place that you don't think there should be. Why is it here?
Yeah, I'm very interested in why there are some of those.
So you have to understand like how the plates are coming together, where the cracks are, where the faults are. Which, like when I started all this stuff, I wasn't all putting this all together, like how one is related to the other.
No, but over time you're catching it, you know, just like the rest of us.
So
the more time we spend on it, you know, the better that we get, you know.
And to me, it doesn't make any sense why somebody could say, well, it's all random, because it isn't.
No, I don't see evidence for being random at all. There are things that we can call it random because we don't know what the hell's going on. But once you start watching things, it's like, hey, this is a repetitive process. This thing's pushing up on this. You know, I think the greatest thing that you drew for people is, you know, basically, you know, a sheet of ice breaking as it goes down a river, and how one part overlaps another part, sinking it or subducting it and crashing up on another, you know, crunching up or raising it up. I think that was probably the best visual for those people like myself who utilize using visual cues to help. But anyway,
I've seen it do all sorts of crazy stuff because I live by a river that floods in the spring.
Well, there you go. You're watching the ice roll downhill, right?
Yeah, it will come up over the banks and make a big mountain, or sometimes it spreads out, or it does all sorts of weird stuff.
Yeah, I played in the mud with water and doing that. That's how I see things too. So, but mine's mud. Yours is
and
ice.
sometimes it makes sheets.
I'd rather play in the mud.
Just like Nick was saying, the pizza boxes. I should do that.
Yep, the pizza boxes. So in this part of the Mendocino Ridge, back to what we're talking about here, this part where the Mendocino, the 2 7s are right there. The uplift that's happening in the south is due to the fact that that's where the window is. The window is in the south. That means there's a separation between the Cascadia subducting underneath North America, which is to the north of the 2 sevens, and the south, what meets the plate boundary of the Pacific plate, which is the San Andreas fault system, because it's transformed. So there's a break, and that's what this uplift right here is that the article said. So this is the reason this is higher, is because there's nothing under there to fill the void. So magma has risen, pushed up, lifted up, so to speak. It's interesting to see that. I don't know how. I know the estimated subduction of the Juan de Fuca, or what's left of the Farallon, is about 25, going underneath North America at millimeters a year. The North America is moving due east, and parts of the west here, moving due west and southwest. Some even in Southern Cal are moving due south, and the Pacific plate's moving northwest. And this little area right here is really interesting. We have the 3 main faults: the San Andreas, the Macamba, and the what was their R1? I forget the R1. Bartlett Springs, yeah. The 3 main faults that are working toward this. And faults of California. If I bring this, because we're going to translate into your next topic here. I think I'm showing it already. All right, good. This is the area that is the slab window right up in here. And they said it's to the south of the Mendocino and to the east of the, I don't know how they can say it's east of the, how can it be east? Is it the slab window is the subducting up here, and then it's torn?
Yeah, it's underneath there.
Yeah.
See, because we've had those 3 6s there basically on land since 2022, the Colima quake, and then now we have the 7 that's slightly further out.
Yeah, we've had a couple of 6s here. We looked at those the other night. Look at the for those who are on Rumble or on YouTube, even on here on Twitch, you can look up the last 15, 20 shows, and look for the last 5 shows you'll get to.
There's a new study from 2024 on those 3 6s since 22.
Do you have that article?
I can find it. I looked at it another time, but see if I can bring it up.
Direction.
When I was studying the quakes up there before, I found it.
Right.
I forget what it's called.
Divergent boundary at the Gorda Ridge. All right.
2000.
Okay. What's interesting here is the Gorda Ridge is this portion. This is the Mendocino. This is the Gorda Ridge. And then this is the Blanco. This is all Juan de Fuca here. The Gorda Plate, which is different from the Juan de Fuca, but they're related, of course. I'm trying to see where the hell the window is. The Gorda Plate is subducting towards due north at a rate of 5 centimeters. The accommodation of this plate configure results a transform boundary along the Mendocino fracture zone. The divergent boundary at the Gorda Ridge. This area is tectonically active today. We know that. It's a spreading center, though. Due to the relative plate motion, the triple junction has been migrating north. We know that. Occurs at a void. The geometry requires a void it's a subjective term here, called a slab wind, a development of southeast of the MTJ. At this point, well, we got to find out. There's an article on that. Furlong Schwartz. Furlong.
Yeah, there's one from 98 where they have pictures of what it looks like under there.
Yeah.
I don't know if that's the one from 98 or not. No, it says 2004 on it. But there's one from
this one's
98.
99.
Yeah, there's one from 98 or 99 that shows supposedly what it looks like under there.
I guess I can try and
I imagine there's a newer one. Probably if you search for it, you'd probably find something newer, I would think. But because that's like 25 years ago now.
yeah. ResearchGate, I got it. Download the text.
Because what I put in there is just talking about the 2021 and 2022 sixes, what it was doing, or what they think it was doing.
See if I can see the. All right, I have it here. Share this tab. All right. So let's go. Boom, 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 boom. All right. Region isotech regional gravity anomaly. Thickened crust is here. That's what we thought. The south edge of the Gorda slab is right through here. Goes right towards Lake, or here's Lake Pillsbury. It's north of Lake Pillsbury. All right. The extent of the modeled region. All right. So onshore, they're saying that's the thickened part. So in looking, here's the Gorda right here. This is the region, the southern edge of the Gorda. All right, so it bleeds off into Cali. And I'm going to find Lake Pillsbury. Black Butte Lake. It looks thickened crust goes all the way down. Well, it's interesting. Clear Lake is part of it. No, it's not. It's north of, it's Mendocino. Little Lake Valley. That's where it stops. So the bottom of that stuff is right in here. The thickening. Right to where the Macamba ends and then turns into the Brush Mountain shear zone. Looking at the map here.
Yeah, because if you read all the current fault studies, they say
Goes around Clear Lake, yeah.
It's all running, all those things are running back into the Mendocino.
The coastal range thrust, yeah, is the dotted line that works out here. So the coastal range thrust is all out here. Wish I could draw on this one. Well, probably I can if I did this. All right. And then, no, don't save. Open. There we go. And then over here, show on stream. Here we go. So according to this, this is the area of the right there is the thickening. according to the article. Actually, it's a little smaller than that. I drew a little bit bigger. So it kind of comes like this. That's the thickening. So the slab window has got to be somewhere in there. And San Andreas stops right here or right here. And the slab, San Andreas, looking at it sideways, you have the crust, you have the upper layer of the crust, the lower layer of the crust. This first part here is up to 15 miles. The other one's up to 30 miles. And then you got the moho, which is up in here. And then you have all the lithosphere, right?
Yeah.
So what they're saying is that is there's a tear somewhere where the San Andreas goes all the way to the moho. So it's 30 kilometers deep or 30 miles deep, whatever. And this slab window goes all the way, that's that same depth. So maybe they're saying that San Andreas ends right here or right here. And then this area through here is where the slab window exists. And then we have the triple junction out here. Right? Unless they call it all the way on shore. Do they call it this spot of the triple junction? Is it onshore?
Well,
Do you know or not?
I think so, because it's going over it, and they're saying that it makes stuff blow up through. So
Right. Triple junction's right here.
like, see, it's even doing that along the Mendocino fracture zone itself, because you have all those volcanoes underwater all the way out all along it, right? So the Pacific plate is still running into that same east-west line, and it's still going way out, right? Which they didn't really explain that part. They were only focusing on the section from
Right.
next to the Gorda plate, but you can follow that way. Which, when you read about the Mendocino fracture zone, which we did in the other episode, they said it goes way out there. Well, why is it doing that?
Right. Right.
So it's kind of funny. So there's a reason why it's doing that, which that's how you get into the lineament.
Well, it's interesting too. They have the Macama fault and the what is it? The Bartlett Springs fault goes right through this uplift.
Yeah, right on up through.
So
and then curves into all those splay faults that they don't even have them all named.
Right.
That run right into where the
right toward the Mendocino, yeah.
And they all curve, like they curve up there at the top, running right into it.
Right. So if the triple junctions here, and we have the Macama fault, we have the Bartlett Springs, right? And then all these kind of like splays like this, and then they start to turn up this way. And this is the uplift.
And they're kind of puzzled because they haven't, the Macama and the Bartlett Springs one hasn't had like a large 7 in quite a while.
Right. It doesn't, in the historical record, there's no 7s up in here. I looked that up too. It's blank. It's blank all the way to San Francisco.
But that doesn't mean it's not going to.
Right. Doesn't mean it won't do it. It's just.
Yeah. Because I think that's what it's doing. It's just how the stuff is coming up and smashing there. Eventually it's going to, because I saw another one that was, I think it was a Tembler one, and they had it was from 2017, I think. And they had like all the stress was there, the
Uh-huh.
coolant stress, and you could see it how they did it, and how like it's all building up there. So probably at some point those other faults are going to try and catch up to what happened in 1906, because 1906 was everything.
Of interesting.
Huh.
Because see that so
Uh-oh, where'd he go?
What happened?
I think Canuck disappeared.
What happened there, buddy? You bounced out.
oh,
It does that sometimes. I think it did it like 2 or 3 times the last time you were here.
and that's like me talking about all this stuff in it.
Yeah. What the heck?
Like at some point, there's probably going to be a 7 right under Clear Lake, so it's not going to go very good for the geothermal plant.
No.
Not going to be good. Since Maycoma is on one side and Bartlett Springs on the other, and it's right in between.
Yeah, if you looked on the historical record on the ocean side, here's it called a Pillsbury Doughboy. Yeah. What is he saying?
Because sometimes it comes up, sometimes it comes down. But that's just studying the last 200 years of earthquakes.
Right.
And
Well, the northern Cal, the far end of northern Cal, below Mendocino, there hasn't been a record that suggests 7s or larger till you get to San Francisco.
This time it's kind of doing like what it did in 1915, except not as crazy.
Right. So that 1915 would mean we'd be looking into something like Mount Lassen going again.
Yeah, you're going to get a bigger quake in Nevada straight in.
Right. And what's interesting is prior to this quake, Lake Alomar was bouncing, and there's a quake on it today, just now, a few minutes ago, with 2.5.
Yeah, because I started studying the swarms both at Tahoe and Lake Almanor. And Almanor always seems to swarm before there's like a bigger
they have so downgraded these 4s. All these 4s were 5s.
89 before the
it's just crazy.
Loma Prieta too. Almanor had a big swarm. So
yeah, let me go to today.
Like it's almost all the stuff comes up and then it backtracks. So it smashes into that line, and then you have everything
right. So
that.
See your theory, and mine is that it doesn't go. The magnetic might, but my theory is that the edge of the Mendocino, which I think California has gone over the top of it, goes right down into the central part of Nevada, and probably somewheres around south of Pyramid Lake into this Carson Sink, Lohotan Valley, Fallon, somewhere out here, and then continues out this way, because you can just sit back here and share this tab instead. Here are the quakes that we just had, the big 7 and a blah, 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 right? Now we got this then out here. But what do you notice? There's a lake right down this.
Well, I noticed it's basically straight east of the main swarm.
Yeah.
Too.
Mm-hmm.
Yeah, Lassen lines up with it perfectly.
Right.
The map. Like,
and Lassen's right there.
Well, I go the whole way across, because if you go to the New Jersey quake, The New Jersey quake we had earlier this year, it's all the same east-west line.
All right. What?
Why I think the grease thing plays into all those grease quakes.
Yeah.
Because it's coming the whole way across, and if you keep going across on that same line,
But does it match? Does it match? Hold on. Let's challenge that. I'm not saying you're wrong. I'm going to challenge it because I want to know it too.
Done it like a bazillion times.
That's all right. Because I don't have much of a memory.
Because I just saw on that list it went off in 1884 at the same time.
There is a Grecian connection here, and I don't know what it is. Here,
Well,
all I got to do is go. I don't even have to draw it anymore. I just got to see, view the grid lines, and right here, the Mendocino's at the 40. All right, between the 40 north and the 40 at 30 degrees, right? Or minutes.
Yeah, Google Earth, it's going to curve it.
Yeah, it's going to allow it. So New Jersey, I don't know where the hell New Jersey is. There's everything. Okay.
Can't see where it's coming. Oh.
Well, no, I got to look. Here's 40 right here.
It'll be New Jersey, Virginia.
Goes right through Philadelphia. Wow.
Yeah, that's where Ramapo.
No, 40 north.
We're
I'm sorry. A little bit more north. What city is this?
In Trenton, it's New Jersey. Those quakes were just a little bit up that area.
40, 15.
We're a little too far north for it to line up with the New Madrid, aren't we?
Let me see.
Well, it crosses over the Wabash fault zone, which runs
basically Pittsburgh. Yeah, just north of Pittsburgh.
It's just not New Madrid because the Wabash connects New Madrid.
Well, yeah, Wabash hits, goes down right in and pushes into that one. Yeah, just
so
south of Pittsburgh, just south of Philadelphia is right on it. The 40 north. We're going all across. 40 north. Santa Cruz. That's out there, right?
Yeah, that's the Azores.
The Azores, yeah, just north of the Azores. And 40 north hits
you keep going,
Portugal.
Take you right into Greece.
Well, it hits the boot and the heel, and hits Greece. Yeah, 40 north is I always think of Athens as being part of Greece. It is, but the northern part is where Mendocino comes across. Yeah, Thessalonica. Right, somewhere in here. And it comes right into Istanbul.
Yeah, the North Anatolian Fault.
Yeah, North Anatolian Fault is right in there. That's 41, just shy of 41 north. Armenia, Azerbaijan. What else is out here?
Across, you get into Armenia and the Bajan.
Wait, where? What's that? What's that big deep lake that's up here? That's in one of the stands has a super deep lake.
Yeah, I can't remember the name of it.
Yeah, there's also a place that's always on fire. I think that's in Africa though.
Like, I'm pretty sure if you keep going across, it comes out in Japan.
We're coming right through here. We had a pretty darn good quakes up here in China and right up in here. Wasn't too long ago. Let me see here. Probably custom. I'm going to put 5. I can't think it was last year. And it was last year sometime. Up to now. Kyrgyzstan, it was banging off of Kyrgyzstan real good. There they are. Yeah, there's a 7 right here. That's 41,256.
We're
And
really,
we're
really off track now, but we're identifying the around the world limit.
yeah, the lineament that goes all around the damn world is right. 41 is right here. So between 41 and 40. And then it comes into northern Japan. Yeah. Just south of Hokkaido and Amori right down there. And it comes back around to the Mendocino. Bang.
Which is why I think the California quakes always happen when the other side is going psycho.
I don't know. Hey, there is a connection with Greece. It's unfreaking canny.
Yeah, that's weird.
He's like, what?
Oh, weird
Really
for me
weird.
because I've seen it like a bazillion times in my
Yeah.
time.
And we talk 1 year before, 1 year after, trying to guesstimate at a geologic time, not a I mean, this is purely not science, it's all subjective. But
Well, not really, because supposedly they can see all this now with the new Landsat 9 satellite.
yeah. Well, they don't want to tell us that now they know how it works.
Which the flying saucers that they have now. Well, now
Yeah.
they have things.
Come on.
They have no engines because you can't hear them. Because
Yeah.
flew over the fisherman's boat and they couldn't hear them, but there was 2 F-22s escorting them.
Yeah, I remember that. That's a recent one too.
Yeah. And they fly through New Jersey and they're all on this lineament that we're talking about. So I wonder if somehow they figured out how to fly these things with.
Yeah. They're riding the magnetic fields, man. That's what they're doing. I think it wasn't a big.
There was 2 of them, and they looked like the Alcash from Stargate.
Yeah,
that's what they look like. And they were flying over the ship, and they took video and pictures of it. And then right behind them was the 2 F-22s.
Yeah,
scared them half to death. Well, they saw them coming, but of course they were flying low, right close to the water.
Uh-huh.
And so you heard, like, when the jets flew by, it was like super loud. But when these 2 other things flew by, they weren't making a sound, and the people, you could hear the people recording on the Fisher
because they're flying magnetics. Yeah.
So I don't know what they were doing, but the 2 things were right silent, and that's what everybody's been talking about now. There's all these drones or UFOs or UAVs or UAPs, whatever they're calling them.
Yeah, you're absolutely right. The quakes in New Jersey were right on that same line. Wow. They happened April, January, February, March.
Yeah.
April 5th.
Even though the fault goes northeast to southwest. And it's like Ramapo, it's a new thrust fault because every quake that happens now, it's on a new thrust fault.
Yeah. See, so what do we say? Well, it's within a year, but you can see here, share this tab instead. All right. Here's New York. New York's on that same line. All right. Triple junction. Goes right through Pittsburgh. Right. All the way over through Salt Lake City. The triple junction. Right. That's the magnetic line that goes all the way around the world. Right there.
So when I look up the quakes, like when I get another list of quakes, I just look and I say, oh, look, 1884. Well, that did the same thing. It was over New York City, and then it did it over at the MTJ the same year.
Right.
On both sides, because it's the plates moving. So if one side is pushed, the other side adjusts.
So in Mendocino Coast, Fort Bragg, intensity is 6.8, 1898, April 15th. So now we go 1898, right? Now let's go open the GIA. Sharing the tab, 1898.
Yeah, I don't remember what was happening in 1898, but
Well, we're just going to look.
you find
know,
out.
it's- Yeah, why not? It's all what we're doing, right?
Mexico was going off, and
18.
Caribbean. I imagine it's all the same procedure.
Mm-hmm.
Like, how many times have we done it already just in the California?
Time and time
Yeah.
again.
Yep.
All right. 91, 95, 96, 97,
And
98.
wait until I show you the end tonight the Nevada list of quakes.
Interplate. That one is Nicaragua. 1898, 429. Northern Japan. 1898.
It's magic, I'm telling you.
Tripoli. It's a little south on Tripoli. And there's Taiwan. 1898. Vanuatu is well low. Mexico. Regito Islands. We just had that.
Yeah.
And then
Gagito went off right before 1906 and Fran quake too. Remember? 7.2, like a week or two before.
Yeah. And then the other one is in Guerrero, Mexico.
Right after you do this enough times, I don't know how anybody can deny it.
Can argue it. Yeah, the Mexico ones are 99, but 97 you have the DR, which popping out a pretty good one.
And I found too the fires all go on the same lines because you've had all the fires in New Jersey this year going right across. It's all the same line, but keep it quiet.
6.5 to a 7. And in 97, the Philippines, too low. 97 was also Peru, Lima. And that was, what's it? A 7.7. I don't know where this one is.
And those 21.
Northern Japan again the year before. Schlong.
The 21, 22 quakes there.
What the
North
hell?
Cali were all the same time that the fires were going off.
What is this one? Mexico, way south. That's Oaxaca.
It's all random. You notice it.
Well, no, it ain't doing anything.
It's just because people aren't looking globally. They're stuck in their zone. Well, I got news for you that.
Yeah. And I'm going to say that also what goes hand in hand with that is with all of our lists is what comes up so many times, but we've been avoiding it, is Japan.
Yeah.
There is a tie with Japan that is significant, and we're not there yet, but we're getting there.
Well, remember in 2011 when that went off, you had the Colorado quake and the Virginia quake. All that thing. There's the line.
It doesn't stop, man. It's
like I could do it with any one. Like if I looked up every East Coast one and then look to the West Coast, you probably see the same thing if I did like every single year. Which I haven't done every single year, but I'm getting close, bro. I keep doing it enough, it's going to be the same thing over and over. I'm going to be able to guess where to look, where I kind of do that right now anyway.
Right, I can do it too almost. But I'm trying to stay on the eastern part of the Pacific plate.
Yeah.
So that I can see it more. I'm having trouble with working with Chile and Argentina and Brazil, but
a year to 2 years time.
Right.
If the quakes are bigger, it does it faster.
Well, they're easier to see because they don't happen as much, but it's the little ones you can start to see. you know. And since we've been doing this, you know, fun stuff, man.
And something has to
Well-
happen in California before you get big quakes in Nevada. That's just how it works. So
Right.
that's what I've learned.
You have something to say there, Clem? Go ahead.
I was gonna say all the little ones just keep ratcheting up the pressure little by little until
Right.
it finally breaks, you know.
I think the little ones are telling us what's going on. You know, they're kind of leading us. You know?
Yeah, they get more noticeable. So then you can kind of figure out when you should be on watch. Right?
Yeah, you should be on watch, right?
Yeah.
Right.
Because you see what it's doing compared to what it's what it's done in the past, right?
Your watch is in Nevada, Lassen, Salt Lake City area right now. That's your line of watch. My watch is in San Francisco area, and I'm not saying it's going to be a 7 or anything like that. You know, I just don't know how much pressure is built up, but I think San Francisco is due for another one, just because of what's been happening. Southern Cal has been banging. How many 5s have we gotten? You know, it's been quiet for 20 years. Now all of a sudden we've got, you know, Tehachapi, we've got Malibu, we got downtown Los Angeles, a few of them. And it's like, hey, all right, something's going on.
So did I give you the link for the Nevada quakes? Or did I don't think I did. Oh,
Yeah.
well, I better do that.
Been waiting on you, buddy. That's how you want to end it tonight. I know.
Yeah, that's how I want to end it because it's interesting. Yeah. Because from all the other ones we've studied so far, you can kind of see, once you see the list of the Nevada ones, it'll start making sense.
Yeah.
So I'll put that in there next.
There they are. All right.
And we could start right with the
God bless it.
Right at the top and go down.
Yeah.
Because 1857, that was same year as Fort Tejon quake. 1860 and then 1868, so that's same year as Hayward Fault. So it's getting into that when we
San
talk
Francisco
about
area, yeah. Like I said, I'm watching San Francisco.
1869. See, it was going crazy in Nevada, and it did it right before Owens Valley, 1872, and then it responded after that before North Cascades went off at the end of 1872. 1887, it went off. That was the same year as the Sonora quake.
Mm-hmm.
Then Reno went batshit crazy 1914-15.
Sure the hell did.
When Lassen and the MK
Lassen went out 1915, yeah. And Lassen didn't just pop once. It popped all the way through 1917.
Yeah, well, it was technically it went from 1914 to 1922.
Okay.
When I read about it.
All right. Yeah, I know it was still smoking and kicking up for a while. Yeah. Most people don't even know that.
So you keep going down the list. 1932, well, that was the same year as the big quake at Colima.
Long Beach too. 1933.
33. Yeah. 34 was right after all this. So within 2 years, all those big ones at
Salt Lake City
went off. Then 54, see all the 54 stuff was like within 2 years of the Tehachapi quake.
Tehachapi was 57, right?
Yeah, and see, look how it went totally nuts in 54.
Yeah.
And see, then it went off in 59, which was the same year as Lake Hebgen. and the big
that's up by the park. And then 92 right there.
responded to Landers,
That's Landers.
and so did St. George, Utah.
Yeah.
And so you have the stuff going off in 2008 again. And then Ridgecrest, and then Monte Cristo. It's magic. Not really, but it's just fun. Like when I started looking at the list all in a row instead of just trying to look them up individually. Because when I'm looking up one year, I kind of look within that year or whatever. But like when I saw them all in like one list like this, I'm saying, because I already know about the other quakes because I've studied so many of them. And I said, look, it's going off of this, going off of that. There it goes. It's doing what it does. And you can see it. Now, I bet if you looked at if you had a list of these like Utah, which I haven't looked for yet, I bet
I'm looking at the Utah one right now, the 92 one, because that's close to St. George.
Yeah.
Zion National Park had some collapses. It was a 5.7.
And like I've looked at some other ones, New Mexico went crazy after the San Fran quake in 1906. It got a whole bunch of quakes all along the Rio Grande Rift.
Why doesn't the USGS have a 92? Why?
And it'd probably be the same thing if you looked up the Arizona ones too, I imagine.
Yeah, I know.
Made it
I'll be getting there.
with all this other stuff that was going on. Like I know Arizona felt the Sonora quake like big time. So did Texas.
And what was that, 1889?
1887.
87, yeah. Seems we had 1887 again.
Yeah, because there's an 1887 in this Nevada list too.
Yes, there is. Oh.
It's all magic. Not really, but
for people, you know.
Not really, not when you start looking at it. And don't limit yourself. Look at every state.
You got to be able to think outside the box, you know, and a lot, and you just have to be able to, you know, and say, well, it is subjective. You know, we're doing a lot of subjective stuff, and that's all right, but that's how you're thinking out the box, because, you know, the idea that Lucy Jones says, well, they're just random. They're not freaking random. You know?
Well, they've never been random.
They've never been random. And there's a reason why they hit in certain areas. You know? And then you can see the system, how it works. And maybe they don't want us to see that, but I just don't think so. I don't give them enough freaking credit, tell you the truth.
To me, there's no way they can hide it because we have access to too much information. Because that's all we're doing with all this stuff. We're taking all these different databases of information and correlating them all together, which is basically what the whole human race just does. It's just we have even more now, right? We have even more info than ever. So the more info we have, like they're getting so much info from the satellites, they can't even analyze it all. So they're giving out all the data to all these different groups to say, well, go figure this out because we don't know. It's too much. We don't know what to do with it. Figure this out. And that's basically what they're doing with everything. So it doesn't matter if it's a drone, a satellite, a friggin' plane, a spaceship, the Enterprise will be flying by before long, and they'll say, look, there's another UFO. It's not a UFO. We just built it. Because we got to get to Mars and
know that sound
before we all blow each other up. But in sci-fi, it's still the same thing when you go out in space. So you either blow yourself up or the aliens blow you up. So it's the same thing.
Right.
So I don't know why they think it's going to be any different if you fly to Mars or wherever. It's the same thing. It's just we might be more advanced, but we're still just the same as what we've always been. It just strikes me funny.
Yep. And it is quite interesting.
Yeah, you bet it is.
And all the aliens fight each other, even if they're a bunch of aliens that all live on the same planet. They're still fighting each other. So how is that any different than here? Well, it isn't.
Buy any of that shit. Sorry.
So why do all the aliens have the same issues that humans do?
You're a freaking slee stack, man. Come on. Oh, love you.
Pretty funny.
You have anything you want to add, Luke, before we close her up?
Another great night packed full of information, guys. It really was.
And we haven't even done the faults in Nevada, but we already jumped into the earthquake. So that's
yeah. We'll have to get the ArcGIS on that. I want the ArcGIS up in Oregon and Nevada, and then also AZ. So I'm going to be looking those up.
Well, we haven't done Oregon yet either.
Right.
Like if we just looked at the earlier list and saw the Blanco fracture zone ones, you can see how it was coming down through into Oregon with those.
Yeah.
I never mentioned those on the list, but that Pacific Northwest list has everything from basic to Mendocino up to top of Vancouver Island that they know about.
I know that
5.5 and above for like 200 years or 150 years.
Where are they? Nick Zentner's, I'm going to pause it because I'm going to show that one. If you haven't seen his latest of Nick Zentner's interview with Megan Anderson about the basement rocks of Silesia, it's a little technical, but it's freaking bitching, man. It's so good. It's only a half an hour long. I recommend you do that. I want to put the link in chat. If you haven't done that, this is one of his latest ones. In fact, is the latest one he's done because he's wearing the same jacket when he came on and said, "Hello, everybody, I'm back." He's going to be on Thursdays at 1 o'clock. 12 o'clock Pacific on Thursdays. So that's 1 o'clock my time. Figure it out, everybody else. It's 2 o'clock Clemmer Doodle's time, right? So
Yes, sir.
and it's probably 3 o'clock Canucks time. Maybe even 4. I don't know.
4 o'clock Canucks time.
4, because he's way the hell out there.
Yeah. So
This is the beauty of being able to be on the internet, man. We can have people. We have from the far eastern part of the U.S., the far western part of the U.S., and we got the central part of the U.S. We have it all.
And then when Simply Sue comes, she's the next day ahead of us. She's in the future.
Yeah.
I always ask her for the lotto numbers for last night's drawing, but
we should ask. We should ask Clem. Oh no, we should ask Sue. Yeah. Sergeant Schultz. She says, "I know nothing." Well, anyway, guys, thanks so much. It's 9:21 here in the big AZ, and I'll tell you, I looked outside and I saw Jupiter. Go, is that a darn plane? It's so bright. Oh my gosh.
People saying it's a UAP or a UAV or whatever they're calling it.
Yeah, just sitting there like, whoa. Then I had to use my phone to see if it was real. Because it was getting a little blurry to me. Well, I've been on the computer here for 15 hours, so. But yep, Jupiter ascending, yeah. Meteor shower next week, she says. All right. Yeah, this was a good one. Thanks so much, guys. Luke, forget about it. Love you guys.
Love you guys. You got it.
Good night.
Good night.
Good night.